If you have ever hand-rolled an agent loop, you know the pain. Storing conversation history, parsing tool calls, retrying, and stitching in retrieval. The Azure AI Foundry agent service takes that whole loop and runs it as a managed, stateful service. In the next 5 minutes, I will give you the mental model, show you what actually happens during a run, the handful of settings that matter, and the gotchas that bite in production. This is a deep dive on the mechanism, not a feature tour. Pricing and model availability change fast, so confirm specifics in the current Azure docs. For nouns, carry the whole system. An agent is a configuration, a model deployment, a system prompt called instructions, and a set of tools it is allowed to use. A thread is a persistent conversation, and the service stores its message history for you, so you are not shipping the full transcript on every call. A message is a single turn from the user or the assistant, and a run is one execution of an agent against a thread. The key shift from the raw chat completions API is that state lives server-side. You create a thread once and keep appending to it. Here is the loop the service runs for you. You start a run on a thread. The model decides whether it needs a tool. For built-in tools like file search or code interpreter, the service executes them and feeds the result back automatically. For your own function tools, the run pauses in a state called requires action, hands you the tool call arguments, and waits for you to submit outputs. Then it continues until it produces a final assistant message and moves to completed. Runs are asynchronous. You either poll the run status or use the streaming API to watch events as they happen. Tools are where agents earn their keep. The service ships built-in tools like code interpreter, file search over uploaded files, Bing grounding for the public web, and connectors to Azure AI Search for your own vector index. You attach external systems through connections defined in your Foundry project, and secrets resolved through managed identity rather than keys in code. The agent picks the tool. The service handles the call and the result injection. Treat tool selection as something you steer with clear instructions and tight tool descriptions. In code, it is compact. You connect to your project, create an agent with a model deployment name, instructions, and a tool, then create a thread, add a message, and create and process a run. The create and process helper blocks until the run reaches a terminal state, handling the polling for you. Notice there is no manual history management. The thread holds it. Now the traps. First, threads are persistent and accumulate. Long threads grow token cost and latency, and stale ones linger unless you delete them. Plan a retention policy. Second, function tools stall the run in requires action until you respond, so a missing or slow handler hangs the conversation. Set timeouts. Third, content filters and rate limits live on the underlying model deployment, not the agent, so capacity planning happens there. Fourth, give the agent a user-assigned managed identity with least privilege on its connections instead of keys. And test tool selection. Vague instructions make the model call the wrong tool or none at all. To recap, an agent is config, a thread is server-side state, and a run is the managed tool calling loop you would otherwise build yourself. The service shines because it owns history, orchestration, and grounding, while you own instructions, tool design, identity, and retention. One concrete next step: spin up a Foundry project, create an agent with a single Azure AI Search tool over a small index, and trace one run end to end so you see the requires action pause for yourself. Then layer on more tools. Because models, tools, and pricing shift often, verify current limits and capabilities in the Azure docs before you commit a design. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.